So in this example, we're being asked to calculate the moment of inertia of a sculpture that consists of 3 small spherical masses connected with massless rods. In order to determine the moment of inertia, we first have to specify the axis of rotation. So the first part that we're being asked is to find the moment of inertia about the axis passing through spheres B and C. And then we have to find the moment of inertia about the axis that passes through sphere A and is perpendicular to the rod connecting spheres B and C. In this latter case, find the kinetic energy of the sculpture if it rotates with an angular velocity of 4 radians per second. So in this problem, the first thing that we're going to do is make an equation for the axes. So here we'll have I is equal, or the inertia is equal to the mass of A times the radius of A squared plus the mass of B times the radius of B squared, and then plus the mass of C times the radius of C squared. So this would be the total inertia for these spheres. And so the first part that we're being asked is to find the inertia for axis BC. So this would be for BC. And then the equation that we can make for this one, we know that the radius of B is equal to the radius of C. And then we know that this is equivalent to 0. So then to find the inertia of BC, we can do that the mass of A is times the radius of A squared. So that's all we're being left with. And then we know that the mass of A is, in this case, we could use any values, honestly. So in this case, we could put that it's times 0.3 kilograms times 0.4 meters squared. And this would give us 0.048 kilograms by meter squared. So that is our value for axis BC. And now let's move on to the other part of the problem. For the second part of the problem, we're being asked to find it for axis A, the inertia. So, since we know that the radius of A is equal to 0, the radius of B is 0.5 in this case, and the radius of C is 0.4 in this case, as we determined in the previous part. So they're all in meters, all these values. So the inertia of A would be equal to the mass of B times the radius of B squared plus the mass of C times the radius of C squared. And then here we would just plug in some values. For the mass of B times the radius of B squared, we would put 0.10 kilograms for the mass, 0.5 meters for the radius, and then we'd square that. And then plus 0.2 kilograms for the mass of C, and then times the radius of 0.4 meters squared. And this would give us a total of 0.057 kilograms per meter squared. That's for axis A. And then this last part of the problem, we can actually generalize both of these answers and just try to get a more general answer. So this would be kind of a part C. So we know that the angular velocity that we're being asked here is 4 radians per second. And then the inertia that we calculated, the inertia of A, is 0.057 kilograms per meter squared. So we're being asked to find the kinetic energy in this case. And the kinetic energy would be equal to half of the inertia of A times the angular velocity squared. And if we just plug in the values that we have, it would be half times 0.057, the inertia of A, times the angular velocity that we're being asked to find, squared. And this would give us 0.46 joules. So that is the kinetic energy that we're being asked to find.